In this video, we're going to do qualitative analysis. We're going to go through all the tests for anions and cations and then go through a question at the end, which people find quite difficult. So well worth watching that. Now, first of all, we're going to go anions, negative ions. Okay, and the tests we're going to do are carbonate test, same as GCSE. You add dilute acid, but we're going to say that acid is HNO3. That's the difference. We're going to say it's HNO3. I'll explain that in a bit. Sulfate test, we're going to use barium nitrate. In GCSE, use barium chloride. Don't use barium chloride. We'll explain that in a bit. And an acid. Now, the acid we're going to use is that one. Okay, HNO3. Lastly, the halide test, same as GCSE, but it's got a little added bit onto it. Okay, again with an acid. Guess which acid we're going to use? Nitric acid. Okay. Now, if that's the case, we're going to do them all at once, and I'll go through that later on in this video. But we go from this one to this one to this one, and we can do it all in the same test tube. And you do it in order as successive reactions until you get a positive result. But let's go through each of them anyway. Okay, and let's start off with our cation. So we have only one cation. So it means you don't need to know metal ions and flame tests anymore. Okay, so you just need to know one cation, one positive ion, which is an ammonium ion. Now what you do is this, okay. We have our NH4 and we add to our NH4 sodium hydroxide. So this is our sodium hydroxide, we're pouring it into our NH4. And then what we'll do is we heat it gently, okay, and that you start to get bubbles, as you can see here, right? And then that turns, and then as you're starting to heat it, you have to do it really gently, otherwise it bubbles up, it starts to produce a steam. Can you see this? This kind of steamy, kind of like wispiness here. That then reacts with this red litmus paper here, and it turns that red litmus blue, okay? So what actually happens is this, is the NH4 that was in there is now here, okay? And that's reacting with the sodium hydroxide. So the sodium hydroxide was in here, remember? Okay, and that is acting like a base because it's going to take that proton off and make water, okay? And the NH4 is acting like an acid because it's donating the proton and turning itself back into NH3. Now NH3 is an alkali. An alkali will turn that red litmus into blue, okay, which is your positive one. So for the exam, here is what you do. You add sodium hydroxide, you warm it, you use damp red litmus, placed in the vapor above, positive test, NH4 plus will turn the litmus blue. Okay, so that is your first test that you need to remember. And that can be anywhere up to like 2 or 3 marks, you see, because you could be asked the equation, you could be asked for any one of these, okay? Now, carbonate ion. Carbonate reacts with dilute acid. Okay, and the dilute acid we told you, hopefully you remember, you're looking at this video and going HNO3. Okay, and bubbles are produced. Now what do you see is the important thing. Now in these exams is what do you see? And what you see are bubbles and what you see is fizzing. And that's because carbon dioxide is produced. Now it's not on the course, but then you often use lime water, which turns milky when it reacts with the carbon dioxide, which was at GCSE, so I've just added it. Now, if that is the case, okay, the reaction is like this. So this is the ionic equation. Okay, so the ionic equation is basically your carbonate ion is going to react with your acid. Remember your acid is HNO3. Okay, it makes carbon dioxide and water. The carbon dioxide is what reacts with the lime water and turns it milky. And you can see it here. So it's just basically like this, and you would have done this at GCSE. Just a tube, and then it bubbles through there, and then that will eventually turn milky, okay, or cloudy. And that is your test for carbonates. Now, if we go from the test for carbonates to sulfates, and we've got a little video on this one. So react with the barium nitrate. Remember it's barium nitrate. Remember it's nitric acid, always dilute nitric acid. Okay, it creates that white precipitate. And you've got your ionic equation again, okay, which is the barium from the barium nitrate with your sulfate going to barium sulfate. And that's a solid, which is your white precipitate that you will see. So question is, why are we using dilute nitric acid and not hydrochloric acid? Because hydrochloric acid is GCSE. It's because if you do this, you'll get a negative for the sulfate. Okay, it won't give you a positive. But then if you do a halide test, it will give a false positive. So what do we mean by a false positive? What we mean is, if you're doing these all together, and I've told you that you can do them in successively. So you do the carbonate, if you get no bubbles, you do the sulfate. If you get no white precipitate, you do the halide. So if that's the case, and you tested and you used HCl, and you tested for sulfate and you got a negative, and then you tested the halides, you would get white precipitate. So you think you had chloride ions when you actually don't have chloride ions, because the chloride ions are coming from the HCl. So we can't use HCl. We have to use barium nitrate because then it doesn't give us this false positive. Now, why add the acid? This can sometimes be a funny question as well. And that's because it dissolves any insoluble carbonates. So if there's a carbonate in there already, which you can get carbonates within some solutions, it gets rid of those carbonates. So basically, you can still test for that. You can still test for that in terms of carbonates themselves can be very insoluble and can come out as white substances. And if they come out as white substances, that basically means that you might mistake them for example, the sulfate, or you might mistake them for a chloride precipitate or something like that, you see. So we add acid to get rid of any carbonates that might be in the sample at this stage. Remember, we've already tested for carbonates at the start, okay? So we just add a bit of acid just to make sure there's no carbonates left, make sure there's no carbonates left, just in case we think they're a white precipitate when actually they're not. Okay. Now, this is what it looks like, and you have got your solution, and then you see, there you go, your barium nitrate, you've got a sulfate here, it's a white precipitate. You can see that clearly. Now we're going to test for halides. If we test for halides, we can see that we have chloride, bromide, and iodide. And with chloride, bromide, and iodide, you get the same colour precipitates. If you add silver nitrate and nitric acid, you get the same colour precipitates as you did at GCSE. Okay, so white, cream, and yellow. If you get white, cream, and yellow, that's the same. But what is different is what you add afterwards. So what you can add afterwards is dilute ammonia, and that makes the precipitate disappear. That means you can tell the difference between white and a cream. Because I don't know if you remember your GCSEs, but it's very hard to tell the difference between white and cream. And even sometimes it's hard to tell the difference between yellow and cream. So what they do in A levels, they will add dilute ammonia. That will dissolve the chloride. Okay, so you see it disappear, so therefore you know it was a chloride precipitate. If you add concentrated ammonia, it will dissolve the cream precipitate and make that disappear. It'll also dissolve this, by the way. So you have to add them in turn, dilute first, then concentrated. And then if you add concentrated ammonia, the precipitate here remains. We're going to go through in a question at the end that really does use this, but let's look at this happening in a video. So you've got 3 tubes here, and with 3 tubes, you've got a chloride and you've got an bromide, okay, and you have got an iodide. So you can see I have put in the silver nitrate and I've got a white precipitate. You can see I've put in the silver nitrate and I've got a cream precipitate, although it's not that different from the white, okay? And then you can see here, I have got, this is our iodide, so chloride, bromide, iodide. And we've got iodide, and that, is it yellow? I can't really tell. But if we put the ammonia in, now look here, starting to dissolve. Now this is dilute ammonia, it's dissolved all the silver chloride, or the chloride precipitate. If we then put it in this time concentrated into the bromide, you'll see it starts to dissolve. And then if we put the concentrated one into the iodide, you can see nothing happens whatsoever. So we can change that into a picture. Let's make it into a picture to make it more clear. So what we're finding, and this is after it's settled out after some time, you can see we have our chloride here, white precipitate. We added dilute ammonia, as you can see up here, okay, and it dissolved. We've got our bromide, and then the bromide, we've added concentrated ammonia, and you can see it has dissolved. We have the iodide. The iodide, meant to be yellow, this is meant to be cream, this is meant to be white. Okay, the yellow has had concentrated ammonia added to it and nothing has happened. So they're your tests to do it. So let's see if we can do it all at the same time. So here you've got the carbonate, the sulfate, the halide. You do it in that order, okay? Nitric acid, barium nitrate, silver nitrate. So we're going to add first of all our dilute acid. We saw no bubbles. Because we saw no bubbles, we know it's not a carbonate. We keep the same test tube, and this time we add barium nitrate. So we add barium nitrate. We didn't see a white precipitate, so it's not a sulfate. Then we look at the halide and we add silver nitrate. we see a yellow precipitate. Because we see a yellow precipitate, we think that's an iodide. Now, I haven't talked about this in the previous slide, but you also need to produce the ionic equations for these. So the ionic equation here is Ag plus I minus go to AgI solid. Okay, and the state symbols are really important because the solid tells you it's a precipitate. Okay, so that's silver nitrate plus the sodium iodide, for example. Okay, and the sodium is a spectator ion and the nitrate is a spectator ion. Okay, so if this was, for example, silver chloride, you just replace the I minus for Cl minus. If it was a bromide, you replace this for a Br minus. Okay, and that's how you do it all in one. And you stop when you get a positive result. So if that gives bubbles, you stop here. If that gives a white precipitate, you stop here. And then obviously this is the last one. So the last question is the really difficult one. And I'm straight away underlining all the important stuff. I saw this once in an exam. It's really, really difficult unless you tried it yourself. So it's getting you to determine all of the things through to A through to F and give the ionic equations for the reaction involved. Okay, so we're going to do it. And I've highlighted all the stuff there and you can see that there. So, first of all, I would recommend going backwards on this. Okay, having a little read at the top and then try and go backwards. So we'll read down it. And then kind of go backwards, okay? So read down it first. So I'm going to start off with two white salts, A and B. So I need A and I need B. Okay, that is my answers. Now if I look at A and B and I go down, right, I'm going to go down to the bottom. It says here, another aqueous portion of A and B was heated with sodium hydroxide. Sodium hydroxide is used for ammonium. Damp red litmus was placed in the fumes, which went blue. Okay, so let's put C, D, E, F. Okay, so we've done that. First of all, we are going to look at A and B. So we know that this consists of a positive ion and a negative ion. It's two white salts, so it's a positive and a negative ion. This is the only thing that talks, if you read all through this, only thing that talks about a positive ion because this is ammonium. So that means whatever our thing is, it is ammonium and they are both ammonium something. So we don't know what the negative one is yet, but we know that. We also know that when you do the test for ammonium, remember you take the proton off, sodium hydroxide takes the proton off and leaves behind ammonia. And the ammonia is the fumes, okay? So basically that's the fumes, so we've got NH3. If you're not sure about that, rewind the video and go back to the ammonium test. Okay, so then we go down, and I've underlined all the important things here. The mass of the precipitate did not change. That means that we must have, we've added concentrated ammonia and the mass did not change. That means there was some precipitate and the mass didn't change. That means the mass didn't dissolve, which means, if you go back to the halide tests, that means you've got an iodide, which means one of these is going to be ammonium iodide. Now, we'll do the other letters as we come up to them, okay? So basically what we've got here, it says excess dilute aqueous ammonia, so aqueous and dilute, it's dilute ammonia was added and the amount of precipitate decreased. Well, there's only one reaction after you've added silver nitrate that makes the precipitate dissolve with dilute aqueous. So with dilute one, and that's chloride, okay? So I've already, from that bit, found out that it's ammonium chloride, it's ammonium iodide. And it's from this bit here. Now it says here, silver nitrate was added and a yellow precipitate E was formed. Can you think of the iodide and the chloride, which one would have the yellow precipitate with silver nitrate? Again, go back in the video, re-watch that part if you're not sure. Okay, so the yellow precipitate E. So yellow precipitate is AgI, okay? And if you're doing the equation, it's going to be Ag plus, remember those state symbols, plus I minus aqueous goes to AgI and then the solid, okay? And then the solid. And that's our ionic equation because it asks for ionic equations as well. Okay, and you can also, if you want to do full equations, for the ammonium test, you can do NH4 plus OH minus goes to NH3, okay? And remember, it's plus that water, okay? Because this has taken the proton off and it's made that water. Okay. Now, we've got C and D to finish off, so let's carry on. Okay, so we found out what this stuff is. Another portion A and B was treated with dilute acid, no bubbles were formed. That's no carbonate. Okay, so we know there's no carbonate anyway, but that confirms there's no carbonate. Okay, and they added barium nitrate, there was no precipitate formed. Okay, there's no sulfate. So again, it all just backs up what we've written already. Okay, and this is the difficult bit that people sometimes don't understand. So 2 were mixed and dissolved in water. Cyclohexane was added to a portion of A and B. And if you're not sure about colours, look at the group 7 video, okay, because the group 7 video takes you through the different colours. So the aqueous brown solution was added and the cyclohexane layer changed to colour D. So I'm trying to remember the cyclohexane colours. Now, first of all, if you dissolve halogens in water, they come out as pale green for chloride, they come out as orange-brown for the bromine, and they come out as dark brown for the iodide. Or the iodine, sorry. Okay, they're the same colour in cyclohexane if it's chlorine, so both pale green in cyclohexane, and they are both going to be orange-brown for bromine. Okay, so the only one that's different is the iodine. The iodine is purple. And let's look at these ones that we've decided we've got. If we put an aqueous brown solution in, and can you think of anything that's aqueous and brown? Well, I can. I'm going to guess that C is going to be bromine because that's brown. It could be bromine or iodine because they're both brown. Okay. If the bromine is added to the iodide, okay, the bromine is more reactive than the iodide. So what it will do is it will replace, and so you get this reaction here, where basically you're going to have, and this is the ionic equation, which means this is more reactive than this, so it displaces the iodide. So you get 2Br minus plus I2. That's one of your equations again, and that's aqueous, 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 and aqueous. Okay, but in cyclohexane, it's going to be purple. Okay, if that is the case, it says D, cyclohexane changed to colour D, that would be purple. Okay, so that would be purple. Now, if that is the case, we've got all our equations and we worked it all out. It's all based on reactivity, because if I add aqueous brown solution and we think it's bromine, and add it to the chloride, chloride is more reactive than the bromide, which means nothing will happen. The bromine will only react with the ammonium iodide. Now, that is the most difficult question you're going to get on qualitative analysis. Okay, most of them will be just, you've added these things to this solution, what is the identity of this solution, or can you tell me how to do it, as in you know the method. Okay, but that's the most difficult one. I really, really hope it's helped. As ever, with all of these, okay, please like and please subscribe for all the other ones, because I produce fun videos as well. Thank you. Okay, but the other one, the other thing is, and that's the most important thing, please share, share, share. Okay, I just want people to get as much use out of these videos as possible, and I hope they help you a lot.